Okay, so far we've been talking. We've done two different kinds of.
Vertical and horizontal?
Yeah, we've done vertical and horizontal. So we've done
What have we done? Motion or
questions,
projectile?
projectile motion. We've done questions where we have our Vy initial is 0 and Vx is 0. We've also done questions where Vy is greater than 0 and Vx equals 0. So that's where it goes up and then down. Vy is greater than 0, so Vy is 10 meters per second. It's going up at 10 meters per second. And we did ones where we throw it down, where Vy is less than 0 and Vx is 0. So those are all vertical projectile. Yeah, there is. And there's also a E and C. Yeah.
So when actually Vy is greater than 0, is that like something about banana boats?
No, when Vy is greater than 0, that's where we're throwing up in the air. Throwing it at the monkey, we have both Vy and Vx. Yeah. So yeah, the first one we're just dropping. Second one is like that, and the third one is throwing it down. Okay, and then the other day and yesterday we did horizontal projectile. Yeah, projectile. And that's where we have Vx is greater than 0 and Vy initial is 0. So two types of examples of that would be either a car driving off a cliff, or another one I didn't talk about would have been like an airplane dropping a bomb or a parachute, somebody skydiving.
Isn't it like a straight down one? Skydiving?
Well,
No, skydiving, you have an initial x velocity because the plane's got x, right? You're moving with the plane, and then you're gonna fall kind of like that.
one parachute can
Yeah.
Well, as soon as you open up your parachute, it's gonna change things. But when you're in free fall, you're gonna have that kind of motion.
It just always looks like the plane's going and jump out and always looks like that.
It
Plane's going
from the plane, it would look like that. If you look from the side, the plane would keep going like this, and the parachuter would kind of fall like that. He'd have some arc to it. And we could do a question like that as an example. Okay. We'll do that after. Today, what we're going to talk about is questions kind of like this, where we start off on the ground and we have, yeah, like playing catch. So here we'll have a Vx is hitting a golf ball as an example of it. Yeah, so Vx is greater than 0 and Vy is greater than 0.
What's V?
V is velocity. So yeah, so Vx, Jory, because you're here, is in the x direction, Vy is in the y direction. Okay, and yeah, it's in the y direction. Okay, so example is Mr. Bennett hits a golf ball with an initial velocity of, we'll say 10 meters per second at an angle of 10 degrees above the horizontal. So Vi equals 10, and our angle theta equals, we also said 10 degrees. right? And it wants us to find first,
What's the title?
the title is,
Don't block it.
sorry, projected level to the ground.
Oh, that's-
For the last bit, show us last page. Oh,
Yeah, you gotta draw the,
draw it or whatever.
okay. So, we have our VI equals 10. That's 10. We have a VY and a VX. All right, from the components. We can just break it down. Right? It's pretty easy. So now we just got to solve for VIY and VIX. Sine of 10 equals VIY over our velocity initial. It's 10. And our velocity y is equal to 10 sine theta. What's it equal to?
1.7.
1.7.
Hey, it's a terrible goal.
Okay,
No, he probably hit the 9-iron.
so not with the 10 degree. That's the driver. 10 degree.
No. Look at how high it is. Maybe look how high it is. Probably ducked it.
But that's in the y direction, right? Is 1.7.
But no, but that's-
So now let's look in the x direction. What our velocity is. Cos 10 degrees is velocity initial x over 10. And velocity initial x is 10 cos 10 degrees.
You have to do that cos 10 equals the VIX is 10 each time. Before we were first year, we just skip that.
That helps you though.
It helps.
It helps you. It should help.
Oh, wait, that's right. Yeah, that's what you said. I like that. This is good.
Where's your bag?
You're a terrible golfer.
So
Yes, I do.
he can hit it 9.8 meters per second in the x direction. So those two are important.
What's a good golf shot?
Well, we'll go over after. So let's find the range of the ball. What do we need to know to find the range? Distance, yeah, our distance in the x.
D equals VI time.
Acceleration.
Well, is the, sorry, with acceleration, is this one going to change at all? Our velocity in the x? No. So we need to find how much time is in there. Yeah,
Using the Y velocity.
using the y velocity. Okay. So if the ball starts and lands at the same position, what's our distance going to be in the y? 0. Our displacement. Yeah, displacement is 0.
Oh, on the X. Oh.
In the y, not in the x.
So, yeah.
No, I know I have.
Yeah. So if we use our formula, velocity initial time
Just check it out, check it out. When you check it out, 1 meter per second. That's what I'm trying to find. We're totally excluding.
0 equals 1.7 t plus 1/2 negative 9.8 t squared. 0 equals 1.7t minus 4.9 t squared.
Are you not factor though, or are you just quadratic?
Which one do you want to use?
Oh, you do
It's a
quadratic.
negative acceleration?
It's a negative acceleration because it's going
Oh,
pulling down. Do quadratic? Okay. We'll do quadratic. Okay, we'll do both. It's no big deal. We got time. So quadratic method.
No, it's like, never mind, I'm doing the factor one.
So t equals minus b, so minus 1.7, plus or minus square root of 1.7 squared minus 4 times minus 4.9 times 0 all over 2 times minus 4.9. This goes to 0.
what is that like? That's a 0 there, that leads to the whole thing.
Yeah, that's 0. That goes to 0. So then we get minus 1.7 plus or minus square root of 1.7 squared is 1.7 all over 9.8 negative. So it equals 3.4 over 9.8, or equals 0 over 9.8. We're not really interested in this one because that's when he hits the ball. So 3.4 divided by 9.8 is 0.35 seconds.
Yeah, it's not very much time.
That's not a very good job. Really, you're terrible.
I think he hit the grass in front of the ball and stuffed it.
Stuffed it. Stuffed it. Give you the benefit of the doubt.
Okay,
It's early in the season.
Ah.
so now we just use our velocity index to find our distance or displacement. V equals v bar. Oops. V bar t.
Why do you do like that?
Well, okay, v bar equals d over t.
What are we trying to find?
We're trying to find our displacement.
Oh, I'm trying to find the velocity.
So the shot was like 2 meters.
He kind of duffed it.
How does it go that high? And it's-
9.8 times 0.35.
Isn't it negative 9.89?
No, that's not our acceleration, Jory. That's this vx.
So these happen to be the same.
It just happened to be the same. So 9.8 times 0.35, 3.4 meters. Not very far.
How many yards is that?
4. Okay, so now the second part of the question. It asks, how high did the ball go? What's the maximum height?
1.7.
So at what time would the maximum height be? Yeah, half. Right? So we can just take our t and divide it by 2.
So like 1.5 seconds.
So t over 2, 0.35 divided by 2. We're finding
1.78.
we're finding our highest height, so it's half the time, right? 1.78. 1.78.
Like, it's what, 0.356.
Yeah. Okay.
That's 5.
So now we can find, we have our time, we have our initial velocity in the y direction, and we have our acceleration. So we can find our displacement. Right?
Yes.
Our velocity initial is 1.7, positive because it's going up. Time is 0.178.
Oh, shit.
And
So the 9.8 is ground.
yeah, in this situation, 9.8 is gravity.
I was like confused.
Yeah, it just happened to be that our Vx was 9.8 as well. So 0.15 meters. So that's like that, half a foot. It's not really that great.